Unit 8, Statistical Diagrams. We start with 8.1a, Data Collection, Extraction, and Presentation. And this part here is pretty long, so I've split it up into two parts, so we'll do 8.1a and 8.1b. In this section, we look at collecting and presenting data. We also look at extracting data from tables and timetables, which we will start with. So example 1. The table gives the distances in miles between some towns and cities. Use this table to answer the questions below. So here's this table. We would find these in atlases, or if you're looking at a road map, to find out the distances between certain places. So, for instance, just to show you how it works, if you wanted to know what's the distance between Derby and Hull, okay, for instance, you would simply go down this line until you met with Hull. Okay, so to go from Derby to Hull, where they intersect, which is right here, that would be 88 miles. We're told that these distances are in miles. Okay, so A, how far is it from Hull to Nottingham? Okay, so we're starting at Hull, and we're going to draw a line down, all right, and until we intersect with Nottingham. Nottingham intersecting with Hull, we get this value right here. Okay, so 73 miles. That's the distance between Hull and Nottingham. B. Andy drives from Leicester to Lincoln and then on from Lincoln to Doncaster. How far does he drive altogether? Okay, so what we'll do is we'll find each one out individually and then add them up. So Leicester to Lincoln, let's do that one first. Also, I'm going to erase these to make this a little bit more clear or easier to follow. So we're going from Leicester to Lincoln. Well, that's not very far. They meet right here. Okay, so the total for that one is 51 miles. Okay, and then we're going to add, then we go from Lincoln to Doncaster. Alright, so again, I want to get rid of that so it's easy to see. We're going to go from Lincoln to Doncaster right there. Okay, so we're going to join these two together, and that value is 39. 39 miles from Lincoln to Doncaster. So we can add these together, 51 plus 39, and that will be a total of 90 miles. C. Ian drives from Hull to Sheffield and then back to Hull. How many miles in total does he drive? Okay, so he drives from Hull to Sheffield and then back. So he does that distance twice. So if we find the distance from Hull to Sheffield, we can just double it to get the answer to C. Alright, so Hull to Sheffield. Starting here, and we're going all the way down to the one on the bottom. Hull to Sheffield looks like this. We can see that it is 61 miles. Okay, so we do a 61 mile journey, or Ian does a 61 mile journey twice, right, there and back. So the total is 122 miles. Example 2. Use the following timetable to answer the questions below. Okay, and you would see this for buses or trains usually. Let's assume this one is a train. Oh, it says right here, A. Alan catches the 2017 train at Cuffley. When does he arrive at Hornsey? Okay, so first we have to find the 2017 train at Cuffley. Okay, first of all, Cuffley is here. Okay, so that's the station, that's the stop. And then, alright, so 2017 is right there, which would be 8:17 p.m. So just as an aside, the way these things work is this going down the column is the same train. Okay, and so for instance, this train here that leaves Welwyn Garden City at 1958, 7:58 p.m., it goes to this stop, and then this stop, and then this stop, and all the way down to Finsbury Park at 2032. Okay, and 58, okay, we don't count all the way up to 100, right? So when we get to 2002, that means 8:02 p.m. Okay, so this isn't 44 minutes after 7:58 p.m. This is 4 minutes after, right? Because 59 minutes and then 60 minutes is then the next hour. Okay, so you just have to remember that when you're looking at these times. So from Welwyn Garden to Finsbury Park, it would take 34 minutes total. But we want to know, we're going from Cuffley to Hornsey on the 2017. So we leave here from Cuffley and we end up at Hornsey, which is down near the bottom right here. Okay, so obviously we stay on the same train, we don't get off, right? So we stay in the same column, and we go from 2017 to 2042. So how long does that take? Okay, we start at 2017. That should be dots, 2017, right? And we get there at 2042. Okay, so that takes 25 minutes. Okay, the time is 25 minutes. Not too bad of a commute. B, Julie arrives at Hornsey at 22:12. When did she leave Palmer's Green? Okay, so first of all we have to find Hornsey. Hornsey is right here. I use blue this time for Julie. So Hornsey, and she arrives at 22:12. So we have to find the one that arrives at 22:12. Oh, it's the last one right here. Okay, so she arrives at Hornsey at 22:12. Okay, so when did she leave Palmer's Green? Okay, where is Palmer's Green? We have to find it on this list. Aha, it's right there. So we have to find in the same row the train that she left at. So Palmer's Green, okay, in the same, sorry, column, not row, in the same column. So if she leaves here at 22:06, she'll be at this station at 22:08, she'll be at this station at 22:10, and this station 22:12. I mean, sometimes they're not all filled in, and that just depends on the schedule. Maybe it's an express, or maybe it takes a different route, or whatever it happens to be. But she goes on this train in this column, leaves at 22:06, arrives at 22:12. So from 22:06 to 22:12, that is not long at all. That is simply 6 minutes for Julie's commute. Example 3. A class of pupils take a test, and their scores are listed below. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 3. We have 30 scores. Draw a stem and leaf diagram for this data. Okay, so stem and leaf, they function like this. Okay, we'll have one column for the stem, and we have one column for the leaf. Okay, and what we do is we decide which one represents what value. So here we have everything ranging from as low as 5, the score of 5, and all the way up to a score of 48. Okay, these are the pupil scores on their tests, as low as 5 and as high as 48. And so we're going to represent that using the stem as the tens column, and then the leaf as the ones column. Okay, so the stem will go from 0, 1, 2, 3, and as high as 4. And then the leaf, well, it'll depend on all these results. So we're going to put them all in there, and then we'll sort it out and clean it up after. So what does this mean? If we had a score of, let's say, 25, well, this represents 20s. This represents 20s. Okay, the stem is the 10s, so this is 20s. So then if we wanted to write 25, there would be a 5 in the leaf because this represents the ones. Okay, this is just single digits, and then 10s, 20s, 30s, 40s. I'll erase that one because I don't know if we have 25 yet. And let's fill this in. Alright, so starting with the single digits. And it's nice to keep track of it by scratching them out once we've used them. So 5 and 7. And those are the only single digits we have. So now let's look at the tens. We have 17. We have another 17. So we write it again. Okay, we're counting all these. 12. And any other single digits? That's it. Now we move on to the, sorry, any other tens? That's it. We move on to the 20s. That hideous 2. 23. And 26. And 21. 29. That's it. On to the 30s. 31 twice. Oh, and I just noticed that I missed a 10, and that happens, and that's why we scratched them all out, okay? So we missed a 19. So we'll scratch that out, and we'll put the 9 in there. Alright, so back at the 3s, or the 30s, we've got a 32, a 36, we've got two 37s here, we got a 38, look, another 19. So put the 38 and also put that 19 in there. This is why we scratched them out. Again, important. 39, 38, 32, 36, 35. So 2, 6, and 5. A lot of people scoring in the 30s and now the 40s. 46, 42, 41, 40. 48, 42, 41. Okay, so these are all the scores. And we can count just to verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Perfect. Okay, so all 30 scores are represented in this messy stem and leaf plot or diagram. So let's clean it up, or let's order it. Alright, and so now what we're going to do is, the stem is fine, it still goes from 0 to 4. However, we should put these numbers in ascending order. Okay, so the single digits already were, but now here we want to go 2, 7, 7, 9, 9. Okay, so we're just cleaning it up. Here we want to go 1, 3, 6, 9. Alright, this one we're going to go 1, 1, 2, 2. And then 5, 6, 6, 7, 7, 8, 8, 9, 9. And finally we will have 0, 1, 1, 2, 2, 6, 8. Okay, so what we've done is taken all these values that have all been crossed off because we used them and organized them into stem and leaf plot that looks like this. Okay, the 0, 1, 2, 3, 4, these represents the tens, and then these single digits here represent the single digits, right? So for instance, a value here would be 29, or this value over here would be 41.